continuation of section 6.2, inverse trigonometric functions. Let's consider that I have something like this, sine of cosine inverse of u. And somebody tells me, write each trigonometric expression as an algebraic expression in u. What are we supposed to do? Alright, well, step one is always to return to your definitions. Your definitions are key. They are what are going to get you out of this. So first off, let's consider that we have this cosine inverse of u. Now, let's write down what is the cosine inverse of u. Well, in general, if you have some angle measurement, I claim that an angle measurement, cosine of theta, is equal to x over r. But of course, that tells us that if I take the cosine inverse of both sides, that theta is equal to the cosine inverse of x over r. And so I can think of the inverse cosine function as an angle measurement, and really the input of the inverse trig functions has to be the ratio of sides when we get some triangle. And so if I have cosine inverse of u, let's actually draw a picture. The picture is where you need to go. If we consider this in its triangle form, we can also equate this to the unit circle form, but if I draw some triangle, and I fix some angle theta, and of course that theta is cosine inverse of u. Well, if you consider both of these two things that I've written side by side, the input of cosine inverse has to be x over r. Well, u could be written as u over 1, which really tells me that the radius, or the hypotenuse of this triangle, must be 1. And the x value, or the adjacent side, must be u. Well, if I have a right triangle, then I can use the Pythagorean theorem to find this, let's call it a y value, thinking about that unit circle application. And I can find y as u squared plus y squared is equal to 1 squared via the Pythagorean theorem. Therefore, solve for y squared, subtract u squared, I'm going to get y squared is equal to 1 squared, which is of course just 1, minus u squared. And we want to take the square root of both sides, and so that means that I get that y is equal to the square root of 1 minus u squared. Here we have a theta, here we have some stuff in terms of u, and so specifically this is now just stating what is sine of the theta in this specific triangle. Well, sine of theta is y over r, or opposite over hypotenuse. Therefore, this is going to be the square root of 1 minus u squared, all divided by 1. Or, of course, that's just the square root of 1 minus u squared. And so in general, return to your definitions and try to draw a picture. So for this one, we want to find what is the cosine of the cosecant inverse of u. And so, of course, cosecant of theta is equal to r over y, which tells us that theta is equal to the cosecant inverse of r over y. Alright, so what do they tell us? They tell us that cosecant inverse of u is really this thing. And so I can say, okay, well, if u is equal to r divided by y, I can consider that this is u over 1, and so I have r over y. That means that r is equal to u, and y is equal to 1. I can draw a picture. Draw that triangle, fix my theta. I know that my radius or my hypotenuse is u, and I know that my y value or my opposite value must be 1, in which case now I can use Pythagorean theorem to find this x value or adjacent side, and so x squared plus 1 squared is equal to u squared. And since I really want to figure out what is this x in terms of u, I'm going to solve for x squared, so minus 1, because 1 squared is 1, minus 1. X squared is equal to u squared minus 1. Take the square root of both sides. At this point, now I know that x is really the same thing as the square root of u squared minus 1. And so now, this is really cosine of cosecant inverse of u, but because of my picture, I now know that that's really the same thing as cosine of the theta in this specific triangle picture that I've drawn. And so cosine of theta is x over r, or the adjacent side over the hypotenuse. And so that's specifically going to be the square root of u squared minus 1 all over u. And so now I've found cosine of cosecant inverse of u in terms of u. Here we want to find what is the sine of cotangent inverse of u. Of course, cotangent of theta is really equal to x over y. So take the cotangent inverse of both sides. That's going to give me that theta is equal to the cotangent inverse of x over y, which, since cotangent inverse of u is the situation I have, I can say, oh, well, that's u over 1 is equal to x over y, and that tells me that I can draw a picture. Right triangle, fix my angle theta. I now know that cotangent inverse of u gives me that the x value, or the adjacent value, is u. The y value, or the opposite value, is 1. And so, use the Pythagorean theorem. I'm going to really find this radius. And so I can remember that u squared plus 1 squared is equal to r squared. And so just take the square root of both sides. That gives me that r is equal to the square root of u squared plus 1. And so now this is the square root of u squared plus 1. And at this point, this is now the sine of the theta in this triangle that I've drawn. And so sine is y over r, or opposite over hypotenuse, which is 1 divided by the square root of u squared plus 1. Now we want to find the tangent of sine inverse of u. So, sine of theta is equal to y over r, which takes sine inverse of both sides, gives me that theta is equal to the sine inverse of y over r, which then allows me to draw, or rather I can say u equals y over r. Well, that's u over 1, which means that r is 1 and u is y. I can draw my appropriate right triangle, fix my theta. Then my radius, or my hypotenuse, is 1. My y, or my opposite side, is u. And I don't know what this is, and so I can find the x. X squared plus u squared is equal to 1 squared. Then solving for x, subtract u squared, that is x squared is equal to 1 minus u squared. Take the square root of both sides, and then I know that x is really the square root of 1 minus u squared. Then this is really just saying, hey, take the tangent of the theta value that we drew in our picture, and since tangent is y over x, that is opposite over adjacent, in terms of u, this is u divided by the square root of 1 minus u squared.